Okay, hello everybody. Now I'm going to present to you about liquid wastewater treatment. But before that, this is an STB 3022 Environmental Biotechnology class. For today, I will present to you liquid waste treatment, which is tertiary treatment. Basically, what is tertiary treatment? Tertiary treatment is a final cleaning process which is needed to remove the nutrient content and to have disinfection to the water before the water is being released to the environment, or either being used as drinking water or even for recycled water. Let's move on to the next presenter, Philip Mandit, and he will be presenting about nutrient removal.
Thank you, Rynier, for the brief introduction on what's going on in the next step, the second phase of tertiary treatment. So basically, just a brief overview on what's going on in tertiary treatment. Tertiary treatment is the last step in wastewater treatment. And in this step, it's basically involves removing of phosphates and nitrates and substances such as carbon and sand that are most commonly used, because these materials we can get it easily. So maybe it reduce the cost of the wastewater management. So in nutrient removal, we got two main processes in which the nitrogen removal and phosphorus removal. In nitrogen removal, it involves two another sub-steps: nitrification and denitrification. In both nitrification and denitrification, bacteria or microbes are needed. So nitrogen removal are basically involved in the uptake into biological cell mass. And nitrogenous compound usually comprises of ammonia, nitrate, particulate organic nitrogen, and soluble organic nitrogen. In nitrification, it basically involves the conversion into nitrate or NO3 negative on the above. So it needs oxygen, in which it is an aerobic condition, requires an aerobic condition. The bacteria needed are nitrifying bacteria, because these bacteria, they are sensitive and susceptible in variety of conditions. Another step is that the denitrification. Denitrification is the conversion to nitrogen gas. In denitrification, it does not need oxygen, which is an anaerobic condition. Denitrifying bacteria, they usually obtain energy from the conversion of nitrate to nitrogen gas. But however, it needs the carbon source as the essential element in the nutrient. Phosphorus removal, on the other hand, is basically utilize the treatment technologies present in the currently present. These technologies involve the physical methods, chemical methods, and biological methods. The physical methods involve the filtration for the particulate phosphorus, and in this physical method, basically uses the membrane technologies. In its chemical ways, involve the precipitation using few chemicals compound. For example, using calcium, which you can obtain from lime, alum, and also ferrum or iron. So other chemical method usually comprises of mixed physical and chemical absorption. And the last step, we got biological. Biological is the assimilation, in which it utilizes this one technology known as enhanced biological phosphorus removal. Now we're going to move on into disinfection, and Rynier once again will explain this part.
I am going to present to you what is disinfection in wastewater treatment. In disinfection, it is a process which is carried out to disinfect or to kill bacteria, protozoa, and other microbial organisms that exist in the water. And in this disinfection process, there is 3 steps, which is chlorine disinfection, ozonation, and ultraviolet light that can be used to disinfect the water. First of all, chlorine disinfection. Chlorine is introduced by sodium hypochlorite, calcium hypochlorite, or even chlorine dioxide. Chlorine compound dosage is determined depending on the demand. it is added to oxidize inorganic compounds and kill bacteria, viruses, and protozoans at the same time. Chlorine residue is removed by adding sodium bisulfite before discharging to prevent harmful effect towards aquatic life. Chlorine, most of the time, chlorine is we can find chlorine in our drinking water because the chlorine is used to disinfect most of the household water supply. Next, ozonation. Ozone is a powerful oxidizing agent. It is the same ozone that made up the protective film that protect us from the radiation, protect our Earth from the radiation. And by utilizing the ozone, it can also disinfect the water by using dry air containing ozone. It is passed through the wastewater using high voltage electrode system. There is an advantage and limitation to this system, which is the advantage is it has shorter contact time, but the limitation to this is that ozone is very unstable in this altitude, so it must be generated on site. Next is ultraviolet light. Ultraviolet light, as we know, it is UV light. UV light can penetrate the cell wall of organism and disrupt the genetic material of the microbial organism. Limitation to this is UV light might not be suitable for water containing suspended solid, turbidity, color, or soluble organic matter, as they will absorb and react with UV, reducing disinfection performance. That's all from us. Before that, we are going to present to you a little short of a video to make you more understand of what is tertiary treatment, disinfection and material removal is. Okay, thank you.
When the sewage is released from the holding tanks, the treatment process starts. Sewage treatment is one great big science project. It's a complex process and we can't do it alone. We need a bit of help from our friends, the friendly bacteria. Fortunately, these happy, hungry guys love all the organic matter in the sewage that we want to get rid of. In fact, it's their favourite food.
That's right. These guys eat all the carbon and reduce the amount of phosphorus and nitrogen in the sewage that can impact the health of our waterways. So we feed them in huge bioreactors filled with lots of oxygen. They can eat and breathe and have lots of hungry babies that eat more and more and more. By now, our treated sewage is looking pretty good, but we need to make sure it's ultra clean. So we filter it, then we disinfect it with ultraviolet rays or chlorine to reduce any hidden germs or nasties that might have snuck through. All the way through our treatment processes, the treated sewage is tested to make sure it meets strict rules. At the end of the process, the treated sewage is called effluent and it's been tested for quality more times than bottled water.